Yes, brought that switcher. That switch is very important. Is going to open and close the switch. This is resistor R1. I'll do one thing. One resistor. I'll bring it here also. Again. Why to do one more separate problem? I'm introducing one more resistor in the circuit. So this is R2. This L. This R1. How you solve this problem? R3 if you want. R3 let R3 be equal to say like a 3 ohm. Let's get into this one. So here what is the method? So let the current here be I. Let the current here be I1. Let the current here be I2 and let the current here be I. I is equal to I1 plus I2. Then polarity plus minus. I'll treat inductor as circuit element. Write down the loop equation. So here I1 is what? Current that is flowing through the inductor. That you have to keep in mind. So let's write the equation. So plus C minus L di1 by IR3 minus L di1 by dt minus I1 R2 equal to 0. Symbols, let me take accordingly. We can't integrate, no, because I and I2 is there. So I should be eliminated. So I'll write one more loop equation here. I and I2 is there, no. So I'll write loop equation now. Plus C I is equal to I1 plus I2. So then this equation will be E minus IR3 minus I1 R1 equal to 0. I'll solve for I1 in terms of I minus I2. I'll write it. Then I'll get expression for I in terms of I2. That I'm going to substitute here. So this should be E equal to minus IR3. I1 will be EIR3 minus IR1 plus I2R1 equal to 0. So replacing the I2 I should replace, no? I1 I replace with, yeah, fine. And this I should replace, so this I will be E plus I2 R2 by R1 plus R3. I think we know all the values, huh? So rather than making problem. This equation will be, what is E? E is 12. Let me substitute value. It become lengthy. This will be 3I. Self-inductance, let me write L only. di2 by dt. R2 value 2 ohm. So 2 I2 equals 0. There's the one equation. So now solving this, E is how much? E is 12 plus I2. R1 is 2, so 2 I2 by R1 plus R3, 2 plus 3, 5. 12 by 5. Okay, now we are ready for this one. So substitute now equation 2 in 1 and eliminate I. substitute 2 in 1. So the I will get eliminated. We'll get only in terms of I2 and dt. So then we can solve this one. So put 2 in 1. Let me take it here. Put 2 in 1. So this will be 12 minus 3, 12 by 5 plus 2i2 by 5 di2 by dt, 2i2 equal to 0. So this 12 minus 36 by 5, 6i2 by 5 minus 2i2 minus di2 by dt. 60 minus, this will be 24 by 5, 5 2 is 10, 16i2 by 5 equal to L di2 by dt. Solving for this, we'll get equation for the current I2. So 24 minus 16i2 5L di2 by dt. L value later on will substitute because 400 milli, or this will become 0.4. Am I right? 0.4. 0.4 into 5 will be 2. So now we'll integrate this 0 to t, 0 to I2. 1 by 16 log of minus 1 by 16 log of 24 minus 16 I2, 0 to I2 by t by 2. Okay, I think this is similar to what we did in capacitor. Please, you have to recollect the ideas of capacitor. There Q by C, here L di by dt. There's only difference. Almost the same set of numericals will come, steady state at t equals 0. So the same mathematics you are coming, the same methods also, the same tricks also you are going to see now. Another alternative method will show what we did in capacitor, the RC circuit. The same thing I'm going to apply here. Now solving this will be log of 24 minus 16 I2 will be 8t. So this will become I2 is equal to 24 minus e to power of 8t by 16. This is the expression for current as a function of time. So like this, I'll get a current in the, what is the direction and magnitude of current through the R1 as a function of time. So he's asking R1. Okay, let's analyze. This is the initial part. I got I2. After getting I2, I'll substitute that I2 here. I'll get I. After getting I, I'll get I1. Now the very good questions is asking us. So these are the B. I'm interested only in this B and D. Please look at these 2 points. So how to calculate now? 24 I'll take. Okay, one more 24 will come here, no? By 24. Yeah, yeah. Okay. I'll do correction, no? So this should be substituting this by 24. So I2 is equal to, okay, no? So we'll make the correction. So anybody final value will be 1 minus 16 by 4.
3 by 2 into 1
3
minus
by 2 into 1 minus e to the
80.
power of minus 8.
Anyone?
3 by 2 into
3 by 2, huh?
yes sir, 3 by 2 bracket 1 minus e power minus 80.
Yeah, okay. Okay, thank you. Then now, okay, this value of I2, I'll substitute. This is equation 3. We'll put 3 in the into, I'll get expression for I. Then I know I and I2, I'll get the I1. Or directly, what is here? We know I. Substituting this, we'll get expression for I1. How the I1? I1 will flow. I1 is a constant or variable. That's what I wanted to ask you. I1 will be variable. How do I can say? So let me take help of this equation. We know I is equal to I1 plus I2. There's a very basic fundamental problem. And from equation 2, so let me eliminate I. So this will be 12 by 5 plus 2 by 5. I2 equal to I1 plus I2. And I know value of I2. I'll substitute here. Then I'll get expression for I1. So this, if I send on to this side, it will be 12 by 5 minus 3 by 5. Now substitute the value of I2 here. We'll get I1 as a function of time, not a constant. This is very important. Sir, there's no inductor. A constant current should flow. No, the potential difference here, the current through the coil will be varying. Here also will be varying. Okay, no, this one. So let's write expression for I1. So this I1 will be 3 by 5, 3 by 2, so 9 by 10. Look at now this current through that branch, will it be a constant? The answer is no. I think I can show only this much. So the current here is a varying current flows here. So I'll write the comment here only. No, so we got I1 positive. So therefore, which will be at higher potential, VA or VE? VB or VE?
V.
VB. So here nearby circuit to write it. Okay, I agree this. This much is there. Okay, now let's come for this. After a long time, what happened to current in all the branches? Will remain constant? Will I agree? So what is the current in I2, I1, I? All will remain constant. So first you put T equal to infinity. What is the current through the inductor? 3 by 2 ampere. Then if put T equal to infinity, put T equal to infinity here. Then how much of current in I1? That's also will be constant. Then I1, I2 are constant. Then I will be constant. So at T equal to infinity, the same circuit. At T equal to infinity, I'll proceed here now. There's a very basic problem. That's why I'm just giving all things in detail. Okay, now let's come for this. At T equal to infinity, how the circuit will appear. R2, R1, this is R3, and this is switch. This is B, this is C. And the current were constant, so let me use capital letters to show that. So what is I2 value? So 3 by 2 ampere. What about I1 value? Put T equal
3
to
by
infinity. How much?
V by 2.
Here also I1?
Sir.
12 by 9. So this is I1, this is I. How much of I? I will be 3 ampere. Now based on the data given, I'm just writing this much here. This is T equal to infinity. So what is the energy stored in the inductor? There'll be some energy will be stored in the inductor. This one, I want this energy stored in the inductor, U infinity. So U infinity should be equal to L I2 whole square by 2. So the value of L we know. Okay, let's have, this is some energy here. Now I'll open the switch. And I'm very sure that V be greater than V. Now I'll open the switch. At a steady state, the switch is opened. So once the switch is open, what conditions will prevail? The battery will be cut off from the circuit. What direction the current in the circuit and various parts is going to flow? I think yesterday I gave some idea of how to get that. So because of switch open now, switch S is open and there's a resistor. So the resistor R3 and E will be cut off from the circuit. No, it's of no use of in the same. So the only the current can flow in this loop. And this is B and this is A. How to get the direction of current in this circuit now? Switch is S opened at steady state. Switch S is opened at steady state. I'll open it. Now, how to predict the direction of current? Can you remember yesterday? Once again, I'll put it because in the end I discussed. Some of you still you assume a ring. You assume a ring. Any direction. So there's a ring. One turn in the, because what is the solenoid? Solenoid is made up of similar to like a rings, no? And let it be in any current. Let it flow in clockwise or anti-clockwise. So I'll assume that the current I2 is flowing clockwise. I'll stand here and I'll see that current is clockwise. Sir, what about anti-clockwise? Let it be anti-clockwise. Any arbitrary direction, either clockwise or anti-clockwise, you assume it. Then if a current, and there's a one turn of solenoid I'm showing. This is the, or you can say side wave or one turn of solenoid. How the magnetic field will be into the plane because of this current I2 flowing through the coil at steady state. Now here suddenly what happens when I switch open, there won't be battery to support this current I2. Is it okay? When switch S is open, the battery is cut off from the circuit, so there won't be cell to support this current I2. Then what happens to the flux across the coil? Starts collapsing. Then from Faraday's law, what is the flux? Flux is negative. Negative flux decreases. d phi by dt will be positive. EMF induced negative. So how the induced current should flow now? The induced current should flow clockwise. So in what direction I should put induced current? Is that okay, all of you? That how is the induced current? How it should flow? In the direction of steady state current. So therefore, the induced current will flow like this. Now the inductor will behave like a cell. Inductor will behave like a cell. Now look at now which is at higher potential, VB or VE? VE is at higher potential. Able to note it out because the current I2 will flow like this. Or I'll show I2 here. Earlier the current through the resistor was flowing from B to E. Now it is flowing from E to B. Now VE will be greater than VB. Potential at E will be greater than B once the switch is open. So only at steady state this happens? No. Before reaching steady state also, you can open switch. In that case, what happens? The energy in the inductor you should calculate at that instant. I should not write I2, capital I2. Current at that instant which is flowing, no, that will determine. So don't think that only a steady state this can happen. At any instant of time, you can open the switch. Then at that instant, what current that was flowing through the inductor, and with that energy open, it will set up a current here. So what is the direction of this I2 now? In the direction of the initial current that was flowing through the coil. Will I agree? I think you should not make a guess here. From Faraday's law, we should analyze here. So this is like a now decay current. So what is the expression for I2? Yesterday I derived it. Now the potential will be EB. Now what all energy that was there in the coil, who will share? The resistors. So this U infinity H1 plus H2 should be equal to how much? U infinity. Then we know H1 by H2. If the resistors are in series, are in series, then what is the total current? The same current will flow. Then the total heat generated in the resistors are, try to see this. This again one more important idea I'm putting. What all the total heat, what all the total energy that was there in the coil will be shared by these two resistors. Then when the two resistors are in series, what is the ratio of power dissipated? It should be the ratio of the resistance P1 by P2 should be equal to R1 by R2. That I'm writing it. No need to integrate. That you can work out here. Then what is the ratio of heat generate? What is H1? Substitute here. H2 in terms of this. H2 what you can write it as? H1 R2 by R1. So what is H1 equal to? U infinity R1 by R1 plus R2. Similarly, what is H2? U infinity R2 by R1 plus R2. So you can directly, no need to integrate. Take help of this thing. So when they're parallel, then what happens? H1 by H2 will be R1, R2 by R1. Go back to Ohm's law, series parallel. Very important. Here the two resistors are in series. How you can see series? Same current flows here. Okay, this the direction of current to the resistor R1 is something very important. It will change it. Earlier, it was flowing from B to E. Now it will flow in the, so I think this is some other current, steady. Okay, this is, let it be I2 dash alcohol. Don't get confused with that. Okay, there's a basic theory. Can we find out this by any other method? Means like, sir, it's something very lengthy. Means this part is very lengthy. So again, the same thing. It's steady state, find out the current through the inductor. And that will be here. You can bring it here. Then how to calculate time constant of circuit? Where all cell is there, replace with short circuit. Then find out the effective resistance. So will be R1 parallel to R3. That effective will become in series. Then the effective resistance as seen by inductor. Then time constant L by R. L by effective resistance. What we did earlier in RC circuit, you can apply here also. Directly you can write this equation. Once you know this equation and somehow you write this, you get I1. So we need